I'm Dror Sapir, and this is Lab 3, Gaussian Beam Imaging Systems. Why did we do this lab? This lab explores the Keplerian telescope and how it can be used to expand a beam. Beam expanders are used for many applications, including laser light shows, but in the scientific field, they're mostly used to obtain a collimated source to use for interferometry. To obtain good collimation, it is necessary to measure how collimated the beam is in shear plate. A shear plate is a highly precise optic with a flat surface and a wedge on one side. It creates interference between two beams, which shows up as straight fringe lines. When the beam is perfectly horizontal, this can be used as an indication of good collimation. In this lab, the shear plate is actually an optical device rather than a single plate, but serves the same purpose. And here's what we did. We designed a Keplerian telescope-based beam expander. First, we aligned the laser to the rail as we have in previous labs. I then mounted a microscope objective and a pinhole that fit based on the calculations made in the pre-lab. I then mounted a 300mm focal length lens to collimate the light and check the collimation with a shear plate. Once the light was collimated, it was then focused again through a beam profiling blade into the photodiode. And here's what I believe is the most important result for this lab. Beam profiling has been done in other labs. What sets this lab apart was the collimation process and the verification of collimation done with the shear plate. I used two different shear plates in this lab to examine the differences between them and the collimation of the beam. The smaller shear plate on the left shows perfectly horizontal straight fringes, which indicates a well collimated beam. The larger shear plate, however, showed imperfectly collimated beam. The fringes are mostly straight but have slight curves. This means the larger plate is more precise and is able to pick up smaller misalignments. This is because the larger device allows the beam to travel further distance before the beams interfere. In conclusion, this lab was overall successful since I was able to build and test the beam expander successfully. I was able to align the laser through the microscope objective and cut off the edges with a spatial filter. The beam was then successfully collimated and tested for proper collimation. The beam was then profiled and the characteristics were recorded. This was a valuable practice for creating a well collimated wide beam, which is often used in industry for analysis of optics and samples.